Chess currency exchange explained. Chess currency is found in each of these three elements: space, time, and material. Chess currency is exchanged from one form to another with every move that is made. The opportunity to move a piece or pawn from the square that it is occupying to a different square costs 1 unit of currency. The square that player moves one of their pawns or one of their pieces to is also worth 1 unit of chess currency. In that exchange, 1 unit of currency in the form of time is exchanged for 1 unit of currency in the form of space. Chess currency in the form of material is exchanged whenever a player captures an opposing piece or a pawn, and their opponent answers by capturing the piece or pawn that was used to make the initial capture. It is also exchanged when a player captures an opposing piece or pawn that was vital to their opponent's defense. The result of the capture compromising their opponent's defense to the point that an even greater attack on the position can be executed with less moves than the number of moves needed by their opponent to mount an adequate defense of the position. That exchange benefited the attacker because the time and material invested into the attack brought them more time, the amount of time they needed to take control of more space. Chess currency in the form of time and material are best understood when measured against chess currency in the form of space. Chess at its most fundamental level is all about the squares, the board itself. Chess currency in the form of time and in the form of material is spent by combatants to acquire space. One must acquire and or control squares surrounding their opponent's king in order to achieve their ultimate goal. Many mistakenly believe that some squares are more valuable than other squares, but this is not correct. The importance of a square is subject to change. The value of it is not. The square E4 is worth the same 1 unit of currency that any of the other 64 squares are worth, but occupying E4, D4, E5, and or D5 can lead to the player who controls one of those squares to eventually moving a piece onto that square. That is a big deal because from one of those squares, E4, D4, E5, D5, a piece can display its full potential. The full potential of a pawn or a piece is determined by the number of squares it has the option to acquire from a center square of an empty board. That is, the number of pieces of land or real estate that the player has the option to purchase with that piece spending 1 unit of chess currency in the form of time. Proper evaluation of chess currency in the form of time and material is made possible once a numerical value is assigned to the squares. Each of the 64 squares is worth 0.314. This is the numerical value of 1 unit of chess currency. The total value of the board is 64 squares times 0.314, which equals 20.096. The value of the pieces and pawns is determined by the number of squares that they have the option to acquire with 1 unit of chess currency in the form of time. Opportunity to move a piece or a pawn from one square to another square. A player moving a queen has the option to acquire at most any one of 27 different squares. 27 squares times 0.314 equals 8.78. A player moving a rook has the option to acquire at most any one of 14 different squares. 14 times 0.314 equals 4.396. A player moving a bishop has the option to acquire at most any one of 13 different squares. 13 times 0.314 equals 4.082. A player moving a knight has the option to acquire at most any one of 8 different squares. 8 times 0.314 equals 2.512. A player moving a king has the option to acquire at most 8 different squares. 8 times 0.314 equals 2.512. That's the fighting value of a king. That's the unit of currency that it has in fighting value. See, the king can fight. The maximum value of each piece and its exchange value can now be clearly seen and proven by the numbers. Math. One queen equals 8.478. Excuse me, one queen, which is 8.478 in units of value, is equal to one rook and one bishop. So if you add those two numbers up, this is exactly what you come out with. Before chess officials got together and changed some of the rules, a player moving a pawn had the option to acquire at most 3 different squares. 3 times 0.314 equals 0.942. Once the rules were changed, that became true for only 83% or 5 of the moves that a pawn could make before reaching the opposing back rank. For the other 17% of the other one move, a player moving a pawn has the option to acquire at most 4 different squares. 4 times 0.314 equals 1.256. 1.256 plus 0.942 equals 2.198, and when you divide that by 2, you come up with 1.099, which is the true potential value of a pawn under the current rules. For the purpose of demonstrating how chess is an expression of pi, I continue to show the material value of a pawn to be 0.942. Now, using that, we can see how a bishop, a knight, and 2 pawns equal a queen. So this is how much a bishop is worth, how much a knight is worth, and how many 2 pawns are worth. They equal a queen exactly. A bishop and a pawn equal 2 knights. It's exactly. A knight and 2 pawns equal a rook. See, this is a knight, 2 pawns equal a rook exactly. A queen and a rook, a queen, a rook, a bishop, a knight, and a pawn, they equal to 20.41. And the 64 squares come up to 20.096, the difference of 0.314. I'm just trying to show you chess's expression of pi. It truly is amazing to me how one can see how all this adds up, yet turn around and say, but this can't be right. Andrew Soltis did this, and I'm a fan of his book, Pawn Structured Chess. I learned a lot when I studied that book. I'm gonna go back. That was many years ago, over a decade. I'm gonna go back and go back into that book again. But I'll read his quote from the magazine, from Chess Life magazine from 1984. And it's not just the average person that I've shared this with. Here is some of what Andrew Soltis wrote in Chess Life magazine concerning the topic. We'll start with the premise that piece value is related to mobility. After all, a pawn is the weakest force on the board because it is usually limited to a maximum of 2 possible captures and 1 advance or 3 moves. In comparison, a knight can have as many as 8 moves, a bishop 13, a rook 14, and a queen 27. If we divide everything by 3 and do a little rounding off, we find a pawn is then worth 1 unit of mobility. A knight, 2.7. See these numbers he got come up with? A rook, 4.7. And a queen is 9. But the bishop is a problem because it would be 4.3 under this formula, and we know from experience that that can't be right. 4.7 rook, 4.3 bishop. But he said from experience we know that that can't be right. I disagree with him. Experience has taught me that the bishop is nearly as strong as a rook, and I use this to my advantage when playing chess. The article was written for the June 1984 edition. A gentleman who I worked with gave me the magazine after hearing my take on the value of the pieces. I'll add the entire article at the end of this. Here's hoping that this explanation of chess currency helps the community see that chess is an expression of pi. So I wasn't going to read this, but since the print is so small, I'm going to read this out, and you can just stop the video if you don't want to see any more of this. What it says is, there's a topic of chess lore I've always wondered about. It's a genuinely interesting subject, but what really provokes my curiosity is that it is almost never discussed. Somehow we've managed to ignore it by saying it is both too simple and too complicated, too complex. What I have in mind is the little chart that appears somewhere near the first chapter of so many chess primers. It purports to tell you the relative values of the pieces, and it usually looks something like this: pawn, 1 unit; knight, 3 units; bishop, 3.5 units; rook, 5 units; queen, 9 units. Sometimes the list is expressed in pawns or points rather than units, and often the numbers vary. The bishop may be reduced to 3.25 or 3, the queen raised to 10, or the rook to 5.5. There are a number of different scales varying from book to book, and that never seems to trouble us. The reason is that while we devour this chart very early and very quickly in our chess education, we forget it almost entirely by the time we get really serious about the game. I can remember memorizing those numbers in the ninth grade to make sure I knew a queen was worth 9 points, 9 pawns, and other such urgent bits of information. But later, like everyone else, I discovered there are more practical and very specific relationships to learn. We find out from experience that, for example, you can usually give up a rook if you get a knight and 2 pawns in return. But that a knight and 1 pawn isn't enough. And by the time we start playing in tournaments, these relationships have become thoroughly ingrained in our chess mind, while that little chart gradually fades away. We grow to believe that only beginners or computers talk about the numbers of points or units they gain from a trade. And we're stuck when we find Bobby Fischer innocently commenting during the annotation of a Grandmaster game: White has a bishop for a knight, or a half a point advantage. Another reason why we forget about the relative value of the pieces is that we discover they are, after all, very relative. A knight is usually worth a little less than a bishop, but sometimes it's worth more. And in some rare times, it is more valuable than a queen. In one of the great primers, Manual of Chess, Emanuel Lasker talks at some length about the exchange value of the pieces, but always using the Latin caution. I can't say that word, cateris paribus. That is, a queen is worth a little less than 2 rooks, all other things being equal. His contemporary, Tarish, was known as the chess teacher of Germany, and he was even more cautious on the subject. Tarish made a few comparisons of piece value in the first chapter of his The Game of Chess, and then 200 pages later confides to the readers: the estimates I gave are completely false for most advanced players. So because it is sometimes inaccurate and because it's not as practical as specific comparisons, we forget about that chart. But on an impractical and thoroughly academic level, the value of a piece is an intriguing subject. How much is a bishop worth? How much a rook? And isn't there some way of figuring it out? The first person to claim scientific analysis of piece value appears to have been Howard Staunton, the 19th century Englishman who was unofficial world champion before Paul Morphy. Staunton wrote an enormously popular book, Chess Player's Handbook, and in it he says the true numerical worth of the pieces could be worked out to 2 decimal places: pawn 1, knight 3.05, bishop 3.50, rook 5.48, queen 9.94. Stone didn't get around to explaining how he did this, but I suspect it was empirical. Some method taking the general statements of the leading authorities and turning them into numbers. For example, if several sources say a knight is just a bit stronger than 3 pawns, you might come up with Stone's 3.05. But consider some other observations from the authorities of 1850 to 1910, the early days of modern chess, when world-class players dared to make such statements. Wilhelm Steinitz said a rook is generally slightly stronger than a knight and 2 pawns, but a shade weaker than a bishop and 2 pawns. That's deep. But Tarrant figured a rook was worth 1.5 pawns more than a minor piece. and Laskin indicated 2 pawns were just enough compensation for the exchange. Lewis Paulson wrote that 2 bishops were clearly superior to 2 knights, and most everyone has agreed with him since. Steinitz went further, however, saying 2 bishops and a knight are slightly better than 2 rooks. And Terrace went even further, saying 2 bishops and a rook were roughly equal to 2 rooks and a knight. 2 bishops and a rook were roughly equal to 2 rooks and a knight. And there was also disagreement about whether 2 minor pieces are better than a rook and a pawn, whether it depends on which minor piece or even which pawn. Terrace concluded somehow that a rook and 2 pawns were worth about a half unit more than the 2 minor pieces. With these and other relationships cited by the super players, you could come up with just about any chart, and no claim at all to scientific accuracy. We chess players often alleged to be the most mathematically or logically inclined members of society should be able to do better. One approach that hasn't been tried yet is to load up a high-speed computer with master games. There's plenty of raw data, since there are more such games played in a typical month these days than in all of, say, 1925, or for that matter, all of the 1870s. But there is a larger problem of figuring out what to do with all those numbers. It's hard to draw any conclusions from a typical Grandmaster game. You couldn't, for example, argue that the number of times a piece moves or the number of pieces it captures proves anything about the piece's intrinsic value. Well then, let's try a simpler approach. We'll start with the premise that piece value is related to mobility. After all, a pawn is the weakest force on the board because it is usually limited to a maximum of 2 possible captures and 1 advance, or 3 moves. In comparison, a knight can have as many as 8 moves, a bishop 13, a rook 14, and a queen 27. If we divide everything by 3 and do a little rounding off, we find a pawn is then worth 1 unit of mobility, a knight 2.7, a rook 4.7, a queen is 9. But the bishop is a problem because it would be 4.3 under this formula, and we know from experience that that can't be right. A Russian analyst once tried to make this approach work by figuring in a special coefficient, dividing the bishop number by 1.5 because the bishop is restricted to 32 of the board's 64 squares. That gives the bishop a value of 2.9 units, a bit more than the knight and a little less than 2 pawns weaker than a rook. But even with this finagle factor of 1.5, there are problems. What about the times when the pawn can advance 2 squares rather than just 1? That would increase its value at the expense of the pieces. And more fundamentally, there's a big difference between the optimal number of moves a piece can make and the real world where a knight 1, king knight 1, can make only 3 rather than 8 moves. Soviet master Gik, taking this to heart, went at the problem this way. To get an accurate look at mobility, you must add the total number of moves a piece can have on every square of an empty board. For example, a king on one of the 4 corners has 3 legal moves, and on any other square on the side of the board, it has 5. Elsewhere, it has 8. So the total mobility of the king is 4 times 3 plus 24 times 5 plus 36 times 8, or 420. Dividing that by 64 squares gives the king an average mobility of 6.56. For the rest of the pieces, Git came up with the pawn 2.18, knight 5.25, bishop 8.75, rook 14, queen 22.75. Dividing around and off, we end up with pawn 1, a knight 2.4, a king 3, a bishop 4, a rook 6.4, and a queen 10.4. Something's wrong here. The bishop can't be worth 1.5 pawns more than a knight, and we know a bishop and a knight are better than a rook. Not exactly equal to it. Maybe Chess Life readers can come up with a new approach. Until then, I'll leave you with the words of Staunton, the same guy who determined a rook was worth 5.48 units. At the same time he made that claim, he wrote, an attempt to establish a scale of powers whereby the relative values of the several men could be estimated with mathematical exactitude appears to be an expenditure of ingenuity and research upon an unattainable object. I disagree. All right, fam. I just wanted to read that in case anybody wanted to hear that article. All right. Peace.